Morning, everyone. Thank you for joining us for the last in our 4 webinar series using marine shoreline design guidelines to improve shoreline stabilization. The webinar series has been sponsored by the Shoreline and Coastal Planners Group, and it was developed by Washington Sea Grant, Washington Department of Fish and Wildlife, and Washington Department of Ecology. Some logistics. We have disabled the participant microphones. So if you have questions, please type them in the chat box you'll find at the bottom of your screen, which you can open by clicking on chat and the chat icon. Also, we have materials for download that we have been referencing throughout these webinars that you can use for yourself following the webinar. And the materials can be found in the reminder that we sent out for today's webinar. And also you can go to the Shoreline and Coastal Planner Group website. The website link here is shown, coastalplanners.org/webinars. We also have the PowerPoint and the recording for all of the webinars listed. We've got number 1 and number 2 up, and number 3 and number 4 will go up later today. And the webinars are being recorded, so you can get access to them and share them as you wish afterwards. Also, after today, you will receive an email with a survey link. Please, please, please give us feedback for any and all of the webinars that you did attend. The survey will cover all 4 webinars. So today, our webinar will focus on sea level rise and shoreline stabilization. As part of the final webinar, we're going to take a look at a very broad look at the best available science on sea level rise for Washington, and also discuss resources that are available to local governments as they undertake this planning efforts for sea level rise. Specifically, we're going to touch on the nexus between sea level rise and shoreline stabilization. And we're going to discuss our current understanding of this complex issue, as well as our knowledge gaps that may impact planning. So we will examine different approaches to address those impacts. We're going to look at protection, accommodation, and retreat. And then we are looking at the cost benefits for each of these different approaches. We are also going to take a look at the MSDG, the Marine Shoreline Design Guidelines, and see what that says about sea level rise and design. And then finally, we will all examine some of the design solutions that we consider for shoreline stabilization, and then consider take into consideration sea level rise for each of those. If you've attended our previous webinars, you'll see we have a special guest today. You'll be hearing from 4 speakers, and I'll introduce myself, and then we'll each introduce ourselves. I'm Nicole Fagan, a coastal management specialist with Washington Sea Grant. Ian.
Yes, I am Ian Miller, coastal hazards specialist with Washington Sea Grant.
Sydney.
I'm Sydney Fishman. I'm the Shoreline Armoring Planning Associate at the Washington Department of Ecology.
And Corey.
And I am Corey Morse with the Washington Department of Fish and Wildlife. I'm a environmental engineer.
Great, thanks everybody. Okay, before we get started, for those of you who didn't join us for the first 3 webinars, I'm going to do a little look back and give you an overview of what we discussed. So in webinar 1, we gave a high-level overview of some of the key concepts that are related to shoreline geology and processes, and we gave an overview of the local, state, and federal permitting environment. In webinar 2, we examined some key elements that make up a site assessment for understanding what's happening with a site's soils, wave climate, and beach sediment, along with a checklist for site visits. We connected those on the ground characteristics then for how do you make a determination of risk on a site, which then leads into a demonstration of need that's part of the regulatory review process, which also helps determine what's an appropriate technique to apply on a specific site. We covered tools that we can find on the shoreline, and these are also excuse me, we provided you with tools that you can use, and these are found on the Shoreline Coastal Planner website, and we sent these out as part of the emails, and it's called the handout book, and also there's a list of references, but the handouts we used included the site visit checklist, a checklist for reviewing geotech reports, a cumulative risk tool, and a checklist for appropriate techniques, and a marine design checklist. So we also provided you with a glossary of terms that have been used throughout this webinar series. In webinar 3, we examined the various techniques available to address shoreline stabilization, and we looked at the good and bad examples of passive techniques, soft techniques, beach nourishment, use of large wood, and hard armor. We used examples to explain how to use the cumulative risk assessment tool. Then we introduced a marine design checklist that can be used to see whether a wider range of issues have been addressed on a site, including the range of options for addressing shoreline processes, water quality, vegetation management, and stewardship. So now we're going to shift gears and turn our attention to how we can think about shoreline stabilization options given the uncertain future that we face from sea levels rising. And to get us started, I'm going to turn it over to Ian.
Thank you, Nicole. So again, my name is Ian Miller, and I'm the Coastal Hazard Specialist for Washington Sea Grant. And want to introduce you today to some of the sea level rise assessment work I've been involved with the past 5 years or so, which culminated most recently in the publication in 2018 of updated sea level rise projections for Washington State, as well as a variety of other guidance for planning for sea level rise that are available on the Coastal Hazards Resilience Network website, the web link for which you can see on the bottom of this slide. Next slide. So I want to start by defining exactly what we mean when we use the term sea level and talk about the concept of sea level rise, especially given that we live in an area with such large water level variations that happen every day. These are water level data collected at the Seattle tide gauge for a 1-week period in July 2019. And I want you to note in particular on the y-axis, in which the water level is shown in as height in feet relative to mean lower low water, that we've got this, large tidal range of 12, 13, 14 feet in Seattle. Next slide. So now I'm going to zoom out and show you those same data. These are water level data that are collected every 6 minutes. The Seattle tide gauge is situated right at the ferry terminal downtown. So we're going to zoom out and show you those same data for a 1-year period. In this case, go back, Nicole, sorry. In this case, spanning from the summer of 2018 to the summer of 2019. Note that the scale on the y-axis is the same, so you can still see that large range of tides that's characteristic for our area. But in this 1-year view, we can also see the influence of spring and neap tides, which are an astronomical cycle that gives us a higher or lower tidal range every 2 weeks. And we can also see some seasonal variations that start to creep into our average water level patterns, with higher water levels in general occurring in the winter that you can see right in the middle of this plot. So next, what's going to happen is every month in this 12-month period on this graph is going to be averaged down to a single value. Next slide. So same exact time frame, same exact scale, but now every month of data is averaged into a single value. So we have an average monthly water level for Seattle. And here primarily what you can see is that slightly higher average water level in the winter as compared to the summertime. Now what's going to happen is I'm going to show you the same exact view, this monthly average water level, but zoomed out now to the entirety of the record from Seattle dating back to 1898. Next slide. So Here you can still see the seasonal up and down, although now it's kind of compressed such that it's some pretty minute wiggles in this pattern. You'll note that there are some years where average water level is extra high. Those in our area tend to be associated with El Niños in particular. But the key thing I want you to focus on, and the key thing that we're interested in understanding when it comes to this concept of sea level rise, is this trend this upward trend that you can see in this average monthly water level. And this is essentially what we refer to as sea level, this long-term average water level over which all of these other daily and seasonal cycles operate. So that is what we refer to as sea level. In Seattle, the rate of sea level rise over this historic period has been on the order of about 8 inches every 100 years or so, a rate that has had some impacts, but it's been very manageable. It turns out, though, that we expect climate change to increase the rate of sea level rise in Seattle and elsewhere, primarily due to 2 processes. Next slide, please. And these are processes that we tend to interact with on a daily basis, and these are processes that are happening at a global scale that link climate change to sea level change. The first is thermal expansion, so the concept that water expands slightly as it warms, and in the ocean basins, that expansion is manifested as sea level rise. The other is the melting of land-based ice, so chunks of ice that are perched up on land, like in Greenland or Antarctica or mountain glaciers. And as that water melts, it contributes new volume to the ocean basins. Next slide. It also turns out that both of those processes are currently observable and are actively contributing to sea level rise. Here, for example, are data from Greenland that are collected by the GRACE Gravity Observing Satellite Mission. This is an animation, and if we're able to play it, what you will see is the map on the left of Greenland, and this covers about a 14-year period from 2002 to 2016, and the colors that are appearing on that map are representative of where ice mass is being lost on Greenland. And then to the right is a time series showing mass loss over time from Greenland. So what you're seeing here is an overall net loss of ice from Greenland, which would then be represented as a transfer of water into the ocean basins, which leads to long-term average sea level change. So those processes on a global scale are observable. Next slide, please. Excuse me. So let's back up for a minute and ask, is sea level rising in Washington? I sort of suggested as much by showing you the water level data from Seattle, but things are a bit complicated in Washington due to vertical land movements. So here are data from 2 tide gauges in Washington state. The bottom one is Seattle. I've shown you that previously. The blue line is that monthly average water level that I showed you in green on the previous slide. And then there's a linear trend line passing through those data. And we can see that sea level rise trend that I showed you earlier. The top panel is average monthly water level data recorded in Neah Bay, roughly 60 or 70 miles as the crow flies from Seattle, in which we see the opposite trend. Sea level is falling in Neah Bay. And this time series, by the way, dates back to about 1935 in Neah Bay. And the ocean in these 2 locations is doing the exact same thing. The difference in trends here are driven by differences in vertical land movement between these 2 locations. Next slide. So for our sea level assessment that we published in 2018, we actually invested a great deal of effort into trying to figure out how the land was moving, so that in part so that we could better understand what the ocean was doing and help people figure out impacts around the state. So this is a representation of vertical land movement observations that we collected for that assessment. We have 3 different data sources that are indicated by the 3 different shapes scattered around this map of coastal Washington. We can derive vertical land movement from tide gauges in the squares, from continuous GPS stations in the triangles, and then what are called leveling sites, which are essentially highway side monuments, survey monuments in the circles, and then they're binned according to their estimated rates, with hot colors being uplift and cool colors being subsidence. So we can then take these data and use them to remove the influence of vertical land movement from water level observations that we make at tide gauges, which we did. Next slide. And here's the result. So if we remove the influence of land movement from the data collected at each of Washington's tide gauges, this is the picture that emerges. You have a thin sort of black line, which is the annual average water level. You see a lot of variability there. And then you've got this darker black line that sort of passes through that, which is the 20-year average water level. The reason we did that is because that is actually what our sea level projections are intended to communicate, is a 20-year average water level. So the black line is meant to align most closely with the projections themselves, which are communicated here as these red lines in this probabilistic framework that we communicated our sea level projections in. And I will get to that in just a second. The key thing I want you to note here, though, is that we do have an upward trend in sea level in Washington state. This is, again, what the ocean is doing. This is after we account for vertical land movement. So we have an observable sea level rise trend in Washington state. It amounts to about 4 inches per century over this time frame. And if things stay that way, we'll be in good shape. That's probably a manageable sea level change rate for most of our communities. But projections do suggest an acceleration that should become apparent in the next few years to decades. And that's kind of represented by these red lines, which again are a representation of our sea level projections. And you can see an indication in those red lines of an acceleration that is a feature of those projections. Next slide. Zooming out to show projections further into the future, we get a better sense for that acceleration, and also sea levels that we assess as being possible in Washington state, communicated in what we call this probabilistic framework. So in this particular figure, you've got time on the bottom axis out to 2100, change in average sea level in feet relative to essentially the contemporary average sea level. We have that observed trend in there in the dotted line. And then we've got a whole series of lines, each of which has a percentile attached to it. And those percentiles are essentially an assessment of likelihood for each of those sea level scenarios that you see communicated there. So for example, the darkest or thickest black line and that gray bar represent something that we can assess as our most likely current projection, something that gets to about 2 feet by 2100, with that gray bar being what we refer to as a likely range. But then we've got these higher magnitude sea level possibilities by the end of century, but assessed at a lower likelihood currently, that are communicated within this probabilistic framework for sea level change. Next slide, please. So what should you expect in your community or for your project? For this assessment we published in 2018, we combine those probabilistic projections for sea level in Washington state with our assessment of land movement to develop localized relative sea level projections for all of Washington state. These were initially served as data tables that you could access with an interactive map. That's what's shown here on the screen. This is actually just recently, in the last couple days, been replaced, next slide, with this interactive sea level rise data visualization tool. that allows you to sort of interactively work with sea level scenarios associated with different timeframes, different locations, different likelihoods for your particular location in Washington State. So it's a really nice tool. Through this tool, you can also still access the native tables that we originally served for our project. For those of you that interacted with those, you can still get at those, which may be most useful if you really wanted to sit down and do some mapping work, for example, or some detailed vulnerability assessment work. Next slide, please. So let's back up again and ask the question, does sea level rise matter? So a little bit about the impacts of sea level rise. One impact is that it makes events like this one that occurred in Seattle in 2012. This is December 2012 extreme water level event, a photo taken at Alki in Seattle. It'll make events like this more frequent and drive the water higher up the shoreline such that we have more time in which the ocean is interacting with things that we value, that we don't want it to interact with. So that's one way in which sea level rise certainly matters for our coastal communities. Next slide, please. There are other impacts of sea level rise as well that are represented in this 4-panel schematic. Obviously, we've got the coastal flooding in the upper left. Sea level rise will make coastal flooding more frequent and reach higher up on the shoreline. Sea level rise can also drive habitat loss along the shoreline fringe, especially in instances where those habitats are unable to migrate landward because they're either blocked by a topographic feature or something like a hardened structure like a seawall, for example. Sea level rise can drive salinity changes in drinking water wells or complicate wastewater treatment along the shoreline. And then finally, sea level rise can drive complex changes in erosion and deposition along the shoreline, potentially leading to erosion surprises in developed areas of the shoreline. Next slide, please. So to explore that risk and also provide an example of a decision-making tool put to use in Washington State, I'm going to show you an impact assessment put together by some of my colleagues at the Jamestown Sklallam Tribe. Again, just as an example. Next slide, please. So this is for a property that's referred to as the Callan property. This is a parcel on the Strait of Juan de Fuca that the Jamestown Tribe owns. And they were interested in doing some redevelopment of this parcel. It had an existing structure on it. And they opted to do this to assess the sea level rise impacts at this parcel using this profile view approach in which they've drawn a profile extending from the ocean upland through the parcel. So you've got elevation expressed here in feet relative to nav D88, and then you've got distance along this profile transect. And you'll notice a couple features on there, both the existing structure and then the road that services that parcel, Old Blinn Highway. They chose a particular planning scenario to focus on. So they were interested in understanding the impacts to this parcel under a relatively high emissions scenario, climate scenario, RCP 8.5. And they also chose to focus on a high magnitude, but low likelihood sea level rise scenario at a 1% chance of exceedance. And then they also were interested in trying to understand the combination of sea level with extreme water level. So they chose an extreme water level event to map, which was the highest water level that they experienced at this site in 2014. And they drew that in blue on, or they started by drawing in blue, sort of the regular high tide on this profile. Next. And then next they added the water level associated with that extreme event, so their 2014 high tide, and then assessed the distance between the seawater and the thing that was valued on that property, that existing structure. And then they started to build sea level rise into this visualization. Next slide, please. So they started with a near-term sea level rise scenario, 2040, and found that by this time they might expect to see water creeping up towards that structure. Next slide. By 2075, again, given that same high tide scenario, we see interaction with the existing structure as it stands. And then finally, they added next slide, a 2100 sea level rise projection using that same high tide scenario, and found that that structure and the adjacent parcel is really unusable by this time frame, given those planning scenarios. So as a consequence of this analysis, the Jamestown Sklallam tribe decided not to develop this parcel in the manner that they had originally intended. Next slide. By way of ending, I've added the links to some of the tools that I've highlighted during my talk, and also my contact information over at the right. I do believe that we have a few minutes for questions now, but also feel free if you wanted to engage with me via email or phone, that would be great as well.
Thanks, Ian. Let's give people a couple of seconds to type in some questions. If you have them, please type them in the chat box. Also, we will have time at the end, but we just wanted to catch any quick questions that you might have. So Ian, it looks like we have a question from Carrie that says, any projection for land uplift or VLM for this site?
So for the example that I showed, the Jamestown Sklallam Tribes example, they did utilize the projections that we published, which do incorporate vertical land movement for that site.
And Ian, is there a way for people to see kind of the underlying vertical land movement numbers that went into it, or is it just kind of baked into the numbers that you get when you go to the SIG website or use that interactive tool or download those tables?
So if you go to the interactive sea level rise viewer that I alluded to in the presentation, and that you can access via the wacoastalnetwork.com website, as you sort of maneuver through different parts of the Washington coast on the interactive map, you will be able to see our assessed vertical land movement for each location, along with its uncertainty. And there are places where vertical land movement is very uncertain in Washington state.
Great, thanks. Now let's just take the questions that have popped up here. Kind of some clarifying questions. First of all, from Kimberly, the current projection is about 4 inches over 100 years, correct? I think that's referring to sea level rise, but Ian, I'll let you clarify.
That is our current, that is our estimate of the current, or of the observed rate of sea level change in Washington state over the last 100 years or so. It is not what we expect in the future. We do expect an acceleration in that rate in the future.
Great. And then we have a couple questions about RCP 8.5. So Linda and Allison are both kind of asking, remind us what RCP 8.5 is, and also what ranges to use, and is RCP 8.5 the worst case scenario? So
since this sea level rise projections are linked to climate change, they are derived in part from climate change models. Climate change models use emission scenarios as inputs, and emission scenarios are plausible emissions trajectories for the future that again are used as inputs for climate models. The current family of emission scenarios is the Representative Concentration Pathway, or RCP family. And there are 4 of them that were utilized for climate modeling. And they basically, each of them is designated as RCP and then a number, which is essentially representative of the extra heat that the global system would hold in association with that particular emission scenario. These are not predictions for the future, and that's an important thing to note. We don't know what emissions will look like in the future. These are used for modelers so that they have consistency across models and they can be compared internationally. So of those 4, RCP2, RCP 4.5, RCP 6, and RCP 8.5, we ended up using 2 of them in our sea level projections. We provided projections for RCP 4.5 and RCP 8.5. And we did that because we decided we needed to leave it to the user to decide what emission scenario they want to plan with and for. Largely, RCP 4.5 assumes an upward trajectory in emissions, which we are currently seeing around the globe. These are global emissions in greenhouse gases until mid-century, and then it levels out. So essentially, it kind of says, the world figures out how to significantly reduce emissions around mid-century. And then RCP 8.5 essentially says the world doesn't figure that out. And we have a continued upward trend in emissions through 2100. So we provide sea level rise projections for both. It's important to note that a lot of the rise in sea level that is projected is what's called baked into the system. So when you look at projections for those two emission scenarios, you may not notice a lot of difference, especially in the nearer term. The projections are essentially the same, for example, for 2050 for both emission scenarios.
Awesome. Thank you, Ian, for clarifying that. I saw that we got a couple more questions, but we want to move on because we do have a few other people presenting. So Bridget, Jacqueline, I see your questions. We'll get to them at the end if we have time. But now we're going to pass it on to Corey, who's going to talk about the Marine Shoreline Design Guidelines, or MSDG, and sea level rise.
Thank you, Sydney. So the MSDG is actually a little bit brief when it comes to sea level rise. So Chapter 4, which is our Coastal Process Assessment chapter, essentially says that you should account for sea level rise to anticipate the impact. So a couple of the summary tables here, table 4.2 and 4.3. I'm not going to go into a huge amount of depth and don't really expect you guys to read all that small text, but know that that's kind of the summary of the impacts to the process and to the various shore types. So it's in context to what the guidelines call the planning horizon, or essentially how long does your project need to be functional. So we essentially say utilize the projections, like what Ian was just discussing, to approximate where your site might end up at the end of the project's life. So I'm going to actually run through some of the expected impact on the shore type, which is essentially what's on that table 4.2, but we'll look at these individually. So the expected impacts of shore type, again, so that in that table that you just saw on the previous slide, there was a summary of what was described in the response to the Salish Sea, the response of the Salish Sea to rising sea levels by Shipman in 2009. So we're going to run through the shore types and really briefly the anticipated response. So for bedrock shorelines or rocky shorelines like you see here, we don't expect a lot of geomorphic response unless that shore happens to have a significant sediment source updrift that would experience higher rates of erosion. And even that response is probably a little bit ephemeral and short-lived. So moving on to our more naturally dynamic shoreline or shore types, which feeder bluffs, they're probably going to experience an increase in erosion. An increase in tidal water levels is going to increase the depth in the near shore, which is going to allow waves to carry their energy a little bit closer to the land and break closer to the bluff. This is likely going to drive some more erosion and an increase in mass wasting events and some accelerated bluff erosion. Next, at our barrier beaches, those types of shorelines, we expect to see a similar response, some increased erosion, higher frequency of overwash, some migration of these features. So if the barrier beach is in a location with a robust sediment supply, which would potentially see increases in bluff erosion, there's some likelihood that we'll see accretion, we'll see some shifting of depositional patterns, and some changes in where that the outlet of that barrier feature happens to be. So then our estuaries and lagoons that are usually characterized by relatively low energy may experience erosion or accretion, depending on the primary source of sediment. So because these features have a much shallower cross-shore gradient, the increased tidal elevation is going to have a much longer impact on the tidal prism, much larger impact on that tidal prism. We'll see a change in the tidal residence and salinity. Estuaries and lagoons or marshes often are protected by barrier features, like I just mentioned. And the response of those barrier features is ultimately going to dictate the change in wave energy on those types of sites. The change in wave interaction with those sites. So in an unaltered natural system, the marsh would likely migrate landward at a relatively similar rate to the rise in sea levels. In more developed areas, or those areas that are characterized by a confining feature, steep valleys, things like that, we'll probably see some of that coastal squeeze, which I believe Ian kind of touched on. And then our river deltas, we're probably going to see a pretty similar suite of impacts. The added sediment source is probably going to result in changing sedimentation patterns, change in the estuarine range, and an upriver migration of that salinity wedge. Of particular interest is the delta that has similarly sized nearshore and fluvial sources of sediments. Remember, fluvial being sediments being delivered from the freshwater. The change in seasonality of the freshwater deliveries of sediments, which we expect to see, to the system are going to interact a little bit differently with the littoral sediment process. So specifically, systems that have a significant snowmelt component that drives the sediment delivery regime is going to see some change in seasonality and the flashiness of that delivery with a change in the way that hydrologic regime runs. So ultimately, it could come with some significant changes to the nearshore physicality as we see a change in how that sediment and when that sediment gets delivered. And then to our artificial and modified shorelines, we expect to see relatively little changes geomorphically. I mean, those tend to be our more static situations. So there's going to be an increase in flooding and damage due to higher water levels and deeper water. But as far as the geomorphic change, we don't really expect to see much, similar to the bedrock or rocky shoreline. And so I'm going to ask real quick if you guys have any questions. I know that was a relatively brief run through, but we're going to move on to another topic. And so I figured I'd ask if we have any questions so far.
We'll give folks just a second to type in questions. And of course, also, if you type a question and we've already moved on, we'll just come back to it at the end. So just give folks a few more seconds, see if anything comes into the chat. Otherwise, I think I will go ahead and move on because it's my turn to talk now. So thanks, Corey, for that overview. Now we're going to discuss the different types of response strategies that are available on the developed shorelines that we have in Washington. So here we're thinking about how to address rising seas in areas of Washington that already have development, whether that's residential, industrial, public sector, etc. And the information that we're sharing in this section of today's webinar is part of a white paper that Nicole Fagan, Ian Miller, and I are co-authoring. So work that we've been doing over the past several months. So when thinking about possible responses available on developed shorelines, these are the major categories or buckets of strategies that get discussed. Many of you listening in have probably heard them discussed before, and Nicole mentioned them earlier. They are protect, accommodate, and retreat. These response strategies are available to many types of what we would call coastal managers or people who make decisions about what happens on our shorelines. And that could be an individual property owner or even a public entity like a local government. In our white paper, we are putting these different response strategies into the context of dealing with erosion and shoreline protection in Washington state. So making that connection between these robust discussions that we had in webinars 1 through 3 about shoreline armoring today, and then emerging discussions about adapting to climate change that are on a lot of people's minds. The first response option that we have in Washington is taking a protection approach using traditional hard armoring methods. So in Washington, this would be things like building bulkheads or rock revetments and the like. The second option is also a protection strategy, but it employs natural materials to provide protection. So this would be a soft shore approach. The second bucket of strategies is accommodation, which encompasses a variety of design and building techniques that exist within the building footprint. So this could mean elevating a home, floodproofing to keep water out of living spaces, or elevating key building systems like electrical or HVAC to prevent contact with water. And then finally, we have retreat from hazardous areas. This can be accomplished through a variety of measures, ranging from voluntary buyout programs to restrictions on redevelopment following damage that occurs. And we are evaluating these different response strategies of protecting with hard armor, protecting with soft shore, accommodation, and retreat in several ways. So for each of those response strategies, we looked at 3 areas. So first, effectiveness and financial considerations. How well does the strategy work in the face of sea level rise? And how much might it cost to implement that strategy and maintain its effectiveness over time? Second, social implications. How might the given response strategy have implications for others, so neighbors or a community, for example? And finally, how might that strategy impact the environment? The goal of this white paper is to highlight how these different implications will create trade-offs. So the aim of this white paper is not to make prescriptive recommendations, but to raise these trade-offs so that coastal decision makers, whether they're homeowners, local governments, or otherwise, can make choices about sea level rise adaptation that take into account the full picture of what's going on the shoreline. So not just the dollars and cents of it, and not just the purely ecological angle that arise with these decisions. So now I'm going to run through the different adaptation options and those different considerations. So first, hard armor. Hard armor is one strategy that we already have decades of experience with, at least in terms of today's conditions. We already know, given decades of experience, that hard armor is effective at reducing erosion and providing some measure of flood protection. However, one of the biggest questions of effectiveness is whether armor will continue to be effective as conditions change with rising sea levels. Even today, we know that well-engineered bulkheads can experience failure during big storms. And as Ian outlined earlier, we only expect the frequency of those kinds of events to increase. Building a bigger and more robust wall theoretically could address this issue, but that might come at greater costs for engineering design and for the materials needed to construct that structure. So other issues that we already currently experience with bulkheads, like erosion on neighboring properties and scouring at the toe of the bulkhead, will likely continue to be an issue for property owners. And this may mean higher costs or more frequent expenditures for maintenance. And as we know from our current management challenges, the decision to install hard armor doesn't just happen in a vacuum. We know that armoring can cut off access from the beach, whether that's physical access or an alteration or loss of waterfront views. So in a residential setting, this might affect property values, and for a community, this can alter people's relationship to their shoreline. Large-scale armoring, like across an entire community, can also bring up social challenges of cooperation and coordination, which might require extra investments of time or social capital and potentially money to achieve community scale shoreline protection. Many of you watching probably are familiar with the ecological implications of hard armoring, so I won't dwell on it. I'll just say that we already know a whole lot about the ecological challenges that come with hard armor under today's conditions, and that these issues will only be exacerbated by sea level rise. So some of those issues include the disconnection between the beach and the upland habitat, loss of large wood and beach wrack, and the decline of habitat for juvenile salmonids and for forage fish spawning. We are also concerned about the loss of the beach itself, illustrated by this figure on coastal squeeze. So with hard armoring in place, the intertidal habitat can't migrate landwards and it gets drowned out. And Ian and Corey also mentioned this earlier when talking about the impacts of sea level rise. So now let's move on to talk about that other protection option, soft shore techniques. Corey gave us a great overview of soft shore techniques in last week's webinar. So if you missed that, go check out the recording that is going to be posted soon on the Coastal Planners Group website. And Corey's also going to talk specifically about soft shore design and sea level rise later today, so stay tuned for that. So what do we know about soft shore effectiveness and financial considerations? So studies in Puget Sound and British Columbia have found that soft shore structures are generally less expensive than hard armor alternatives at 1/3 to 1/2 the cost of a comparable hard structure. And we also know that Washington is beefing up its options for financial assistance to homeowners to install structures like this, for example, through incentive programs like Shore Friendly. Really, the biggest question we have about soft shore structures are their effectiveness to control erosion and flooding, especially under sea level rise. Even today, we know that soft shore techniques are not appropriate on all shorelines, like Corey discussed last week, and they must be designed appropriately in order to work. That's a key caveat. But we also know that soft shore options have been used in Washington for decades, and we are continuously building a body of evidence that these types of designs can last for many years and perform as desired. For example, Tolney State Park, shown in this photo, which has been in place since the 1970s. Some soft shore designers here in Washington are already reporting that they factor sea level rise into their designs, mostly by designing berms to be taller and wider. It's hypothesized that soft shore techniques are more adaptable to changing conditions, given that they are not fixed in place like a concrete wall. And this gives them some inherent ability to move and adapt with changing conditions. So for example, gravel berms can move up the beach as water levels rise. Soft shore stabilization techniques can provide risk reduction services while also maintaining or even enhancing shoreline accessibility and aesthetics. For example, this is a community on Island County which regained walking access to their beach and improved aesthetics by switching from hard armor riprap to a soft shore solution. Soft shore stabilization techniques, as you probably know, are promoted throughout our region because they are viewed as less ecologically impactful than hard armor. Given that soft shore techniques do not create this rigid, immovable structure like bulkheads do, they may avoid some of the ecological issues like coastal squeeze that can arise with hard armoring under sea level rise. So here's an example of a very well-studied armor removal site. It's called Edgewater, and it's located down in Olympia, where this big bulkhead that you can see on the left was removed, and ecological processes like landslides were allowed to occur, bringing large woody debris and sediment down to the beach. So moving from protection to that second suite of techniques called accommodation. Accommodation, as I said, it's a whole suite of techniques to address flooding. Many of these techniques are likely familiar to you since they are already in use on our shorelines and they are known to reduce flooding risks. So this suite of techniques includes floodproofing, so dry floodproofing, which keeps water out of living areas, and wet floodproofing, which allows water to pass through or under a building with minimal damage. The second tool in this toolbox is structure elevation, so raising a whole building up on pilings or on fill, and then also building system elevation, so moving electrical components or HVAC or other systems that keep a building livable up on a higher floor to avoid flood heights. Here's just a couple examples of homes in our region that have been elevated specifically to address flooding. This first one here is on Guaymas Island, and it was elevated due to flooding. And the second example, a home located on Camano Island, and this home was elevated in response to flooding specifically caused by king tides. So high water level events like king tides give us a glimpse of what sea level rise may look like on our shorelines, kind of like that photo from Alki that Ian showed during his presentation. Given the wide range of accommodation techniques and also the very site-specific nature of construction, it can be a little bit challenging to generalize the financial costs for these techniques. But we do have one local example, a study published last year focusing on Island County. The authors, Cote and Demansky, they worked with a local company, Northwest Structural Moving, to hypothetically estimate the costs for elevating different sized homes. So they evaluated smaller homes, less than 1,500 square feet, up to larger 5,000 square foot homes, estimating the cost ranges that might be incurred just to elevate that house. It's important to note that this doesn't include additional costs that might arise, for example, permitting, dealing with foundation issues, dealing with utilities and things like that. But it's instructive to kind of understand the cost ranges that we're talking about for this one accommodation technique. Also important to keep in mind with accommodation is that there's an overlap with FEMA's National Flood Insurance Program, or NFIP, to consider when talking about finances. Not all accommodation techniques, but certain techniques are recognized by FEMA as being compliant with the NFIP, and homeowners or property owners who adopt them could potentially lower the flood insurance premiums on their property. So while the initial cost to incorporate accommodation techniques into a design can raise those initial costs, there might be cost savings over the long run from lower insurance premiums and potentially damages avoided. If you're curious about these, there are folks whose entire job is to understand FEMA standards and the NFIP. So we definitely recommend consulting with your local floodplain management authority for information on potential flood insurance cost savings. A major selling point actually of accommodation is that these techniques are broadly used on coastlines today, and in many instances are already regulated by local building codes. Vertical elevation and things like floodproofing are not new concepts to shoreline homeowners, regulators, or construction professionals. They're kind of a known quantity. Furthermore, accommodation techniques can be employed to protect a wide range of structures, including critical infrastructure, existing homes and businesses, and also developments that are planned for the future. These attributes make accommodation approaches easier for homeowners or building managers to conceptualize and implement. Accommodation strategies allow coastal residents and businesses to remain in place, and it can also encourage additional development in flood-prone areas. Naturally, this avoids disruption to economies and to communities, and thereby supports community vitality and well-being. However, infrastructure that supports a community, like roads, would also have to be made more resilient if homes or businesses remain near the shoreline, which might require increased public investments to support a potentially limited number of residents. So those trade-offs on the social side are important to keep in mind. On the ecological side, accommodation techniques are usually employed within the building footprint and therefore have fewer direct ecological implications, positive or negative, than shoreline hard armor or soft shore stabilization structures. By designing or retrofitting buildings with potential flooding in mind, structures themselves are just more tolerant of periodic flooding and might not require protection from armoring. So this could allow for the preservation or restoration of shoreline processes and habitat in developed areas. However, accommodation strategies may result in environmental consequences if harmful materials remain exposed to flooding. So septic systems, which I just see a question that popped up about septic. For example, these septic systems or wastewater treatment are, relatively more difficult to elevate out of a flood zone, just given the way that they operate. And therefore, they are likely to fail if exposed to floodwaters, which could potentially release sewage, bacteria, and excess nutrients into the marine environment. So it's an ecological risk that you have to consider. So finally, the last response option we have, or that we discuss in the white paper, is retreat. So moving homes, businesses, and other infrastructure away from natural hazards. First, let's review the different approaches for implementing retreat in coastal areas. There are several approaches to retreat that fall under what we're calling the voluntary category. So they're not implemented through a regulatory authority, but rather through voluntary options. So in our white paper, we highlight buyout programs, voluntary structure relocation, and community relocation. Buyout programs, which you might be familiar with, typically involve making public funds available to purchase at-risk properties from willing property owners at market rates. Around the US, there's a long record of using FEMA funds for purchasing properties in flood-prone areas through various programs at state and local levels. In Washington, programs like Floodplains by Design have bought out over 700 riverside properties since 2013. Public funds to date have not really been used in Washington for coastal home buyouts, but coastal programs do exist in other states. For example, after Hurricane Sandy, the Blue Acres buyout program was established in New Jersey, and as of 2019, they used those funds on over 700 properties in coastal flood hazard zones to purchase and demolish those properties, and that was partly with those FEMA funds that I mentioned. Property owners may, of course, voluntarily choose to relocate their structure away from a shoreline in response to flooding and erosion, and we do have a number of examples of this option throughout coastal Washington. So this is a photo of a house on Whidbey Island being moved back from a bluff due to erosion concerns in 2018. And also a number of tribes in Washington state are actively implementing coastal retreat as a preferred alternative to reduce their risk from coastal hazards. For example, the Quinault tribe spent many years developing a comprehensive relocation plan for their entire community to address future anticipated flooding and other hazards to tribal governmental infrastructure. And this plan also designated locations up on higher ground for individuals to voluntarily relocate their personal homes to that higher ground. So on the flip side, we have regulatory approaches. Regulatory approaches for making space along the coast generally fall into one of these three categories: avoidance, abandonment, and relocation. And the overarching idea is to use existing regulatory tools to respond to sea level rise by preventing development or redevelopment in hazardous areas. Tools for avoidance, like setbacks and no-build zones in hazardous areas, are actually currently implemented in Washington state. For example, you might be familiar with setbacks that can help protect structures from hazards such as landslides. And then on abandonment and relocation, these are potential regulatory responses following damaging events. For example, local governments could use the condemnation process to achieve abandonment in cases where a damaged building no longer has things like a septic system, sewer lines, or safe access that would be deemed as necessary for that property to be habitable. From a risk reduction standpoint, removing or relocating development from the shoreline is effective. It gets a check mark. So basically, by reducing any new development that's at risk or moving existing structures and services out of the erosion and flood hazard zones, coastal managers they reduce potential damages. And this also reduces or eliminates the need to construct protective structures or use accommodation techniques. Of course, people are going to ask, what about the costs? So this table should look a bit familiar, but instead of talking about accommodation, this time it's evaluating the hypothetical cost to move different sized houses, ranging from 1,500 to 5,000 square feet. Again, these numbers do not include additional costs that a property owner might incur for things like permitting, foundation, utilities, things of that nature. It also does not consider the effects on property value. So property value might be impacted by loss of aesthetic value by being farther from the shoreline, but also a property might gain value with reduced risk, or by being able to have a larger yard or deck with that freed up space. So the authors of this study that we're pulling this table from, they concluded that moving a house can be a viable alternative to protection, especially when other strategies cannot effectively reduce risk. For example, when there's a risk of slope failure due to upland conditions or a very minimal setback on the property from that bluff. On the social side, retreat, we fully accept it and want to highlight that it can be very challenging for property owners and communities to accept. The idea of retreat raises a lot of deep-seated issues for people. It hits on private property interests, development pressures, and also the sense of community and connectedness that we have to the shoreline. Additionally, retreat strategies often aren't seen as viable by coastal planners in urban settings, where you have things like very dense development because of issues like cost and land use constraints. You know, if you can't move the house somewhere, what are you supposed to do? So these are real challenges that we recognize. And on the note of voluntary buyout programs, these types of programs offer, you know, perhaps the most politically acceptable method of retreat. However, locally funded buyout programs can struggle to be viable when there are limited financial resources that must be allocated between different interests. There can be some difficulty in justifying the use of public funds to pay a private property owner for their land. In addition, once that land is purchased by the government, that governmental entity has to pay for the upkeep and maintenance costs of that property so that it doesn't just become an eyesore to the community. Additionally, regulatory relocation approaches might be associated with legal implications that a local government might want to consider. Legal actions might arise from, for example, property owners challenging a local government for imposing regulations that enforce actions such as buyouts or managed retreat efforts. So in Washington State, regulatory structures that we have, they currently allow for the implementation of things like setbacks and buffers. You know, we have them all along our shoreline. The legal implications for imposing development restrictions within those setbacks or imposing concepts like rolling easements are certainly going to require further examination if they were to be implemented. Retreat does have a lot of upside for ecosystem functionality because it means that structures are no longer anywhere close to the nearshore environment. So without a home in a hazard zone, existing armor could be removed because it doesn't need to protect that structure anymore. And if we have regulations in place that restrict future development, we know that those shorelines can remain untouched and unarmored because, again, new structures aren't going to go in place that would later need armoring. And another key concept, this open space that is allowed on the shoreline would also allow shoreline ecosystems and structures to migrate landward as sea levels rise, which avoids the issue of coastal squeeze and allows habitats to reestablish themselves at new elevations on the shoreline. So in researching the state of our knowledge for this white paper, naturally we identified a lot of things that we don't yet know, these kind of outstanding limitations and gaps. So on design issues, the collective we of practitioners in Washington, we need to know more about how hard and soft shoreline stabilization techniques are going to fare under sea level rise, and how these how current structures that are already in place may be able to adapt, and how we might need to design structures differently in the future. On economics and financial considerations, I think time will tell about the maintenance costs and replacement needs for hard armor and soft shore protection structures. And as more property owners undertake accommodation and retreat, we'll get an even better understanding of those costs and how they compare to those other options. On the ecological side, we need to continue evaluating the potential benefits to the environment that things like soft shore can bring, and the harms that might come to ecosystems with rising sea levels. And we also need a better understanding and actually valuation of the ecosystem services that are provided by the nearshore environment and how sea level rise might impact those services that humans value. And finally, we are still learning about how the existing regulatory, legal, and political systems are going to respond to sea level rise. And ideally, a better understanding of sea level rise impacts and potential response options will lead to more robust action in the realm of governance. So with that, I'm going to pass it to Corey to talk very briefly about designing with sea level rise in mind. And then I saw we got some questions. We'll save those to the end because Ian and Nicole might also want to respond. So I'll pass it to Corey.
All right, thank you, Sydney. Let's take a look at how we might design for sea level rise with the various techniques that we've got in the Marine Shoreline Design Guideline. We'll start with passive techniques. So passive techniques are actually pretty resistant to sea level rise, mostly in that there's not a lot of project components that rely on super well-defined water levels. So vegetation will likely see some changes, but those areas that need salt-tolerant vegetation will move up the slope. So there may be some benefit to using some salt-tolerant or semi-salt-tolerant vegetation further up the slope to anticipate that transition. I'm not aware of any studies that have been performed to support this, but my expectation is that the vegetation zones will transition at a rate relatively similar to the sea level rise we expect to see. Erosion control and water management will continue to be a great way of stabilizing a slope. The only issue that would be the change in elevation that these structures may need to be placed at, or potentially adjusting the anticipated elevation that a structure may need to be that happens to be susceptible to wetting or salt spray or something like that. And the last of the passive techniques in the guidelines is relocation, which apart from the process changes we discussed earlier, only becomes more advantageous with sea level rise. So the next technique is our soft techniques. We'll start with beach nourishment. It really is going to depend on the level of existing impact on the drift cell and the level of protection necessary by that offshore protection. So consider the process. In a healthy drift cell, high water levels should result in higher water levels should result in an increase in wave interaction with the bluffs and beaches, which will increase the sediment supply into the drift cell. This will result in increased deposition in the accretion shore forms and ultimately a maintenance of the process. So there may, then this is not necessarily supported by research, but I anticipate that we might see some compression of our drift cell along shore. So we might see the accretion shore forms work their way further up into the drift cell, and we might see the feeder bluffs work their way further down into the drift cell. Just as a result of the changes in wave interaction, if we see bluffs getting mined a little bit more and seeing our accretion shore forms growing. So following that reasoning, if the process isn't intact, soft techniques generally will adjust accordingly. So now things get a little bit cloudier if that process is impeded or if the site requires a more robust protection. So for beach nourishment specifically, like we see here, an increase in berm elevation on the shoreward side would buffer against some of that change in wave dynamics. And a wider berm generally is going to help resist failure of that berm by sliding or by toppling as a result of the change in bathymetry at the face of that structure. And similarly, if the waterward face of that structure is relatively steep. And the other thing is the increase in wave energy may justify a little bit larger gravel size, particularly if that's something that's already anticipated to need a little bit more larger and stable core. And when it comes to large wood, I would expect we can extrapolate an increase in large wood recruitment as a result of the increase in bluff erosion and mass wasting. Ultimately, this is going to lead to more recruitment on our beaches and our accretion shore forms, and really to draw an analog to the fluvial or the freshwater process or zone, the success of large wood in a system for either erosion control or habitat is really quite heavily reliant on the recruitment of natural wood. So, an increase in erosion might actually be a benefit in that way. So now where impacts to design arrive are when wood in a project needs to be anchored for its success. So consider if wood is added to a project for erosion control and it's placed in a location, that doesn't require anchoring, an increase in water levels and an increase in wave energy, that wood may just float away. So potentially it becomes critical if the beach is bluff backed or has no back beach because the potential impacts of suspended wood against the structure of the bluff behind it will potentially be much more likely. So I mentioned it in the previous webinar, but to reiterate, the easiest way for a project to be unsuccessful for large wood is for that wood to be placed too low on the beach and for that wood to be anchored. So if we're elevating the tide levels, like we expect, then every piece of wood that we place is going to be down, well, likely every piece of wood that we place is going to be in that failure zone over time. So wood that's unanchored, too low on the beach, it's going to result in that wood mobilizing or potentially just adjusting its location, maybe just leaving the site, which isn't necessarily a huge impact or a huge negative. But wood that's anchored or placed too low in that tide range is going to experience the same forces that would mobilize them if they weren't anchored, but they're mechanically stabilized, which is going to result in some scouring, potentially some exposure of anchors, or even some failure of those anchors. So that leads to the need to modify design, either by unanchoring or by repositioning, to plan on the anticipated water level and wave energy changes by moving wood further up the beach or construct a berm if that happens to be incorporated. So to increase the resilience and resistance to mobilization, I would offer rather use larger and more complex wood. That could help without necessarily having those negative impacts, and then also using more dense species, which we generally recommend in the first place, things like Doug fir or madrone, in lieu of things like cedar or alder. So that could also minimize the likelihood of those poor results. So then when it comes to reslope and revegetating, the guidelines are actually silent to the impacts of sea level rise on the reslope and revegetating type projects. But the impacts can be pretty easily assumed or guessed at. The biggest impact will be the change in sediment and wave dynamics with the site. So if the site happens to be in a transport zone that happens to be near the transition, there's some likelihood that your bluff or slope could turn into a feeder bluff or could feed more frequently, or your beach or back beach could transition into a more accretion type feature. So I've already touched on the implications of planting a little bit earlier and on vegetation types, so I'm going to kind of leave that there. And then the next technique we talked about is bulkhead removal, or the restoration technique. Ultimately, the implications to bulkhead removal of sea level rise are impacts to the natural setting. So we already kind of ran through at least the discussion on geomorphology of those settings. So the effects of bulkhead removal with anticipated sea level rise will probably be more aggressive. And I'd refer you to the discussion that we had earlier on those individual shore type geomorphologies and the earlier discussion on the guidelines. So removal of bulkheads, particularly where infrastructure is removed or absent, as far as a habitat perspective goes, allows marsh and beach migration processes to occur without the coastal squeeze that we expect in the more developed areas. And then on the last item that we talked about in the guidelines for hard armor, accounting for sea level rise in the design of hard armor really comes down to elevating structures to account for the acceptable level of inundation and risk and anticipating the higher energy. So potentially structures may need to be higher up and a little bit bigger. The issue that comes to mind when considering hard armor in the face of sea level rise is the aggravation of the issues that are going to already be occurring with that type of site. Particularly vertical walls in a well-worked beach area results in vertical action of that wave energy such that the beach will potentially lose its upper portion and become disconnected from the back beach. We talked a lot about that as we were discussing earlier. And if water levels rise and waves are acting further up and potentially further in, we'll see more regular issues of waves breaking on that vertical face and further impacting the upper beach or potentially even mid-beach after sea level rise. So like Sydney already touched on, hard armor is not just generally compatible with the dynamic environment. We talked about it also on webinar 1, I believe. And so when additional dynamicism, tough one, is introduced to our setting, it becomes even more impactful on that static structure. So while soft and passive techniques can be relatively easily modified or may just work with a changing water level, hard armor is a little bit more difficult to modify structurally without a wholesale removal and replacement. I'm going to pass it on to Nicole, but before I do, I'm going to answer a quick question that we got Question about the grid planting on the back beach of that reslope. I don't know exactly what the plantings were. That's out of the Lurs Landing project, offshore project that went in a while back. And I believe it may just be planting cones or individual, I'm trying to think of the word for it, but supports for the plants that were placed there. So I'm not 100% sure is the answer. All right, so I'm going to pass it on to Nicole to go ahead and wrap us up.
Thank you, everyone. Thanks to Sydney, Ian, and Corey. What I want to do is we're going to turn to questions, but before I do so, first of all, I want to remind everybody, first of all, thank you all for joining us, and thanks for the questions we're going to ask, and we're going to give you more chance for questions, so please be typing them in while I'm doing this. And this is a real challenging topic. We know it's evolving and changing with new information. And so we definitely welcome feedback and the comments, and we're sharing resources with you. Again, I want to reiterate the Coastal Hazard Resilience Network has most of the information that Ian referred to. In addition, there's a guidance on considerations for incorporating sea level rise in restoration projects, and that has some really important information that you all can use. The other thing is we want to ask you to please help us with these webinar series by giving us feedback. So later today or tomorrow morning, you will get an email with a link for a survey. Please let us know. It's for all 4 of the surveys. So if you've attended all of them, please give us feedback on all of them. And if you've only attended this one, please give us feedback on this. Also room for telling us what other information we should be providing information on. So thank you for those who've attended our previous webinars. Thank you for sticking with us over the past month. And everyone who attended, please keep an eye out for those, the survey that will be coming out. And with that, I'm going to let Sydney go ahead and go through some of the questions, and she'll field questions, and then we'll all take turns answering them. So go ahead, Sydney. Sydney, are you there?
Yes, sorry, can you hear me now?
Yes.
Sorry, oh my gosh. Bridget said, I'm appreciative of all this work, but I've heard from a few folks that these projections are on the low side. Ian, that this is a question for you. Can you comment on that?
Yeah, I sent Bridget a personal answer, but I'll address it for everyone. So the probabilistic framework is actually intended to sort of convey the full range of uncertainty in you know, close to the full range to the degree that we can understand it of uncertainty in future sea level. And so you could certainly make a strong argument founded in the literature that the best estimate of 2 to 3 feet is on the low side. But you know, the probabilistic framework includes magnitudes of sea level change of up to 7 or 8 feet for Washington by the end of the century. They are assessed at a lower likelihood, but they can't be excluded as a possibility. So the reason that one of the reasons we adopted that probabilistic framework was that there is uncertainty in future sea level. And it's hard to, you know, there is no one number that you can plan for. You have to sort of integrate that uncertainty into planning and decision making. And we feel like the probabilistic framework sort of provides the best sort of way to think about that uncertainty and the best way to make decisions around that uncertainty.
Great, thanks, Ian. Another question for you from Jacqueline. Following an earthquake event, wouldn't the land potentially drop? And if so, wouldn't this change how sea level rise would impact an area that was experiencing lift?
That is correct. For large subduction zone earthquakes, and especially for the Pacific coast of Washington. That process is called co-seismic subsidence. It is thought, the evidence, both from models and from geologic evidence, suggests that it's not a process that we would expect to be at play in Puget Sound. However, in the interactive sea level rise viewer, in addition to the vertical land movement for every location, as you scroll around the map on the viewer, there is also an assessment of possible co-seismic subsidence at each location associated with a large earthquake. And we do think that, especially on the Pacific coast, you know, it's worth considering that if and when you're doing sea level planning.
Great, thanks, Ian. Let's see, we had a couple comments from George Kaminsky, and then Corey responded. I'll let folks read those because I want to make sure we have time for questions that were asked. So a question from Linda: what is the best resource for landowners who have had recent shoreline landslides and are considering engineering to stabilize their property? Well, Corey typed in something about DFW's perspective, getting a local habitat biologist involved. Another resource that we really want to promote is the Shore Friendly program, which is actually a network of organizations that have coverage all over Puget Sound, at least, that provide resources to homeowners to help do site assessments, educate homeowners, and potentially even help homeowners consider specific designs related to, you know, addressing erosion concerns on their property, addressing armor, soft shore, things of that nature. So we will go ahead and we'll put a link to the Shore Friendly website in our chat box for folks who are interested. I think Shore Friendly is also linked on the Coastal Planners Group website list of resources, and if not, we can add it there. And then folks, depending on their region, can find the Shore Friendly organization that best works for them. Nicole, do you have any other resources that folks might want to know about specifically for landowners?
Yeah. One thing I wanted to suggest also is the Green Shores for Homes program and the website. And a lot of that is based on the information that you find in the Marine Shoreline Design Guidelines, but gives you a lot of information on information and techniques and resources to look at for how to address various issues on a site.
Great, thanks, Nicole.
And we'll put that in our resource list, which I don't think is there now.
Okay, we'll make sure that gets added. We had a question from Carrie about accommodation of septic systems. We touched on that briefly in terms of just thinking that, you know, while you can elevate a house, things like septic kind of have to be in the ground in order to work. And so accommodation specifically can be a little bit difficult for structures like that that are very dependent on being in a specific location. Ian or Nicole or Corey, do you have any other comments about septic system accommodation, or is it just kind of that's what we can do?
You know, the only thing that I would note, and I'm pretty, you know, noting that there's a lot of people out there that know a whole lot more about septic systems than I do. But in a project that I was involved with on the Strait of Juan de Fuca, you know, we sort of, there's a variety of different types of septic systems that people that we interacted with that know about septic systems were able to sort of at least qualitatively assign different sensitivities to flooding to. So I think that, you know, in terms of accommodation, you can look at a different type of septic system that may be more able to handle flooding. I don't know if that's accommodation because it's kind of replacement, right? But at least something to think about.
Great, thanks, Ian. Let's see, Bridget asked, can we share the Cote and Domansky report? I put a link to that in the chat. And then another kind of report related question, which journal have you or will you be submitting this white paper for publication? And also curious if a notification will be sent to this group once the white paper has been published. Ian, I'm looking at you because you're kind of the lead author and kind of runner of the grant who's supporting this publication.
Yeah, I was about to just post the link. It'll be posted to the WACoastalNetwork.com. It'll be published to that website, since it will be one of the suite of products that we've developed associated with what's called the Washington Coastal Resilience Project. So the sea level rise projections themselves, along with sort of all the associated guidance, is all published through that website.
Great, thanks, Ian. And I just put a link to the Washington Coastal Hazards Resilience Network website in our chat, and the website was just updated within the last couple days. So also, just encourage everyone to go check out that resource, and that's where you can, when the white paper is completed, where we will be posting it. Let's see. I believe that covered all of the questions that we had in the chat, since Corey already addressed Allison's question about the planting. We'll give folks another minute if you have any last minute burning questions, but we are also close to wrapping up for our time. So as we wait for any burning questions, just want to thank everyone again for joining us, whether this was your first time listening or even your fourth time listening to our webinar series. We've had a really great audience. We really appreciate it, you turning out, and we also would very, very much appreciate it if you would give us feedback in the survey that we will be emailing to you very soon. It's very important, especially as we assess whether these webinars and other types of webinars are a good way to deliver information to the types of audiences that we want to reach. Again, contact info for all of our presenters are listed on this slide. We again encourage you to check out the coastalplanners.org/webinars website to see recordings, see PDFs with speakers notes of our slides, and also for all of those links and handouts that we have put together for you. Again, not seeing any more questions, so we will go ahead and sign off. Thank you, everybody. Have a great day.